Hello, everyone. Welcome to this unit, data structures and algorithms. First of all, I would like to introduce myself to you. My name is Uchenno Geni, and I'll be teaching this course or this unit with Darlene. Today being the first time we are meeting, our focus will be to introduce data structure and abstract data types to you. There are other parts of these lectures, this unit, which we will not be discussing today. Darlene is going to discuss that with you during the tutorial section. He will be telling you about the coursework. He will also be telling you about exams, if there will be any. He will also be discussing with you about other activities. There are some weekly activities and other things you need to know regarding this unit. So let's move to the next slide. At the end of this workshop, it's expected that you should be able to say a lot about data structure. And you should also be able to say why data structure is essential for designing and efficient programs. You should be able to describe different types of algorithms, describe an abstract data type, and explain the difference between abstract data type and data structure. And lastly, you should be able to give examples of stack and queue abstract data types. So the first question we're going to have is what is a data structure? If you approach it this way, data structure consists of two words. The first one is the data and the second one is the structure. So if you put an arrow from the structure going to data, it implies that you want to operate on the data and your focus is on the structure that you're going to give the data. So if the focus is on the structure, then you should now be talking about how the data should be stored and how the data should be organized when they are being stored. Then that will help you in facilitating the way the data will be accessed and the way the data will be modified. And this data structure is also used to solve problems. But one thing you have to understand is that no single data structure works well for all applications. This can be said in another way, that no particular data structure is capable of rendering a solution to all kinds of problems. So in that case, you need to know the strengths and weaknesses of all the types of data structure. And if you do know all of them, or most of the strengths and weaknesses, you should now be able to know when and where to apply each of them. So just like a carpenter, he must have to use the right tools in order to do the job efficiently. Now, still on the definition of data structure. So in this part, in this slide, data structure consists of two parts. One is the collection of elements. One thing I want to quickly add here is that this element, we call it element here. In other places, you might be called data. Okay. So, and at some point, it might also be called nodes, N-O-D-E. So the collection of elements, and is also looking at how the elements are associated or how they are related. So the elements can be a data type or another data structure. Then the association will be looking at how is the element or are the elements associated. So a good example of a simple data structure is an array. And why is it a good example? It is because an array consists of data and a structure. So the data in the array is in a linear form, and the structure is how these data are being linked or associated together. Now we've spoken a lot about data structure. Let's now look at the algorithm. So an algorithm is a well-defined computational procedure that takes some values. The value could be is data, they're referring to data. And when it takes the data, it processes the data and gives an output. So this is talking about algorithm. And another thing that is talking about is that the algorithm must be efficient. It must be efficient. So we can't say that you have good algorithms and you have bad algorithms. If an algorithm is not efficient, you can literally say that this algorithm is not a perfect algorithm. But if it is efficient, you can say, yeah, that this algorithm is a perfect algorithm. So we are going to see examples of what we mean by being efficient. Let's compare these two algorithms that sums n integer numbers. This is the algorithm 1, and the second is algorithm 2. Both of them are performing the same task. The first one is using the loop to sum the number to n from 1 to n. And the second one is just using an equation to get the sum of the number from 1 to n. So the question here is, which of these two do you think is the most efficient or the efficient one? So by mainly looking at this is going to take the time of getting the sum. And if you are running this program, it's going to go for the loop where you have to, the loop needs to start from 1 to n and assign to I, and the sum will be calculated, and it keeps going until the number of, until n, and until nth number. So n could be any number, it could be 10, 20, 1, 2, 3, any number. But this is just an expression. The algorithm 2 is just an expression, and it's just a one-line expression that could be executed quickly and very fast. So now look at these two algorithms, or algorithm 1 and algorithm 2. Which of them do you think is the best? Or which is you think is more efficient? Of course, the algorithm 2 is more efficient than algorithm 1 because it will consume less computational cost than that of algorithm 1. So now at this point, the efficiency we are now looking at is time. But there are other things that will be seen as factors that are linked to efficiency. At this point, we're talking about time. Is it quicker? How long is it going to take for it to process? Do you really agree? Yes, I believe you do. Now, if we move further, this part is talking about the classification of algorithms. Yeah, there are lots of algorithms, classifications of algorithms. But in this lecture, we are going to consider these 4. The first one, the brute force algorithm. This is a kind of algorithm that considers all the possibilities and selects the best solution. For instance, if you are playing a chess, you realize that before you make any move, you try to consider all the possible moves and pick the best, make your choice by choosing the best move among all that you've considered. So this is a good example of brute force algorithm. One thing that is good about this is that it's simple and it always finds the solution since you are looking at all possibilities. That's one good thing about it. But if the number of possibilities begin to increase, then so the number of possibility grows exponentially as the number of items increases. Okay. Then the next one is the divide and conquer, the divide and conquer algorithm. This divide and conquer algorithm works by recursively breaking down a problem into two or more sub-problems. The idea is that it keeps breaking down the problem into smaller units until it becomes simple enough to be resolved directly. That's what divide and conquer algorithm, the approach the divide and conquer algorithm takes. A good example of this is the sorting algorithm and the binary search algorithm. And the next one is the backtracking algorithm. The backtracking algorithm attempts to complete a search for a solution to a problem by constructing partial solution. So it keeps constructing partial solution with and ensure that the partial solutions remain consistent with the requirement of the problem. So that is how the backtracking algorithms works. For example of it is finding route to a maze. And the last but not the least is the greedy algorithm. So this kind of algorithm takes decision as soon as the optimal solution is found. It doesn't need to wait to confirm if that optimal solution is a global solution. It just takes that optimal solution as the best solution and goes with it. So the next slide is saying, what is this unit about? It is about data structure and algorithm. So if we want to choose the right data structure for a particular problem, then you have to simply consider how the data need to be stored and how the data need to be retrieved, and also how the data need to be manipulated. So these are really very important steps to take before you make a choice of the data structure that you want to use. Then once you've made a choice of the data structure you want to use, then you have to write an algorithm to solve the problem. And that problem must be solved efficiently. This will be discussed further in efficiency will be discussed further in workshop 2. So in this module, you'll be studying how data structure can be, how data can be structured to ensure that the efficient processing of the data for a particular problem. And then classification of data structure. One classification of the data structure is a linear structure. That's one. In linear structure, linear structure comes with unique predecessor and a unique successor. An example of them is this the stack and the queue data structure. If you look at these two, you realize that, for instance, this element here, it has unique predecessor and a unique successor. Likewise, this one. And if you look at the queue, that is exactly what is happening. So one thing you need to understand and keep in mind is the linear structure, how it is structured is in linear form. Then the next one is the hierarchical data structure. This has unique predecessor, but many successors. It's just like the family tree, where you can have a father, you can give birth to a son, and that son can have more than one child. Or in an organization, management structure, where you can have the head, and under the head, you have a lot of people working under the head in different fields. And the next data structure is the graph data structure. The graph data structure has many predecessors and many successors. A good example of it is the railway map, where you have different points going to different locations, and one point going to another different locations, and just here and there, there's no particular um, organized means of linking them. Also, another example is a network of computers. Then we have set data structure. Set data structure has no predecessor and no successor. A good example is students in the class of data structures and algorithm. Okay, the first activity here is activities 1.2. So in activities 1.2, you have two terms. One thing you have to note about these two towns is that they have the same number of houses, they have the same number of roads, and all the roads are the same in terms of length. Now, if you are required to visit each house in each town only once, and you're also required to that in each town you must have to start your visiting from first home, that is home one. So now, if that is the case, you will have a question, and that question is, why will you walk twice as far in one of the towns? Why do you think you can walk twice in one of the towns? And another way to ask this question is, which of them do you think is the most efficient? Is it town one or town two? If you look at term one and you want to start from house one and you want to start from house one and go to house two, then you must have to come down here, go to house two. And if you have to go to house three, you have to come down again before you go to house three. But in this town two, if you want to go from house one to house two, you just have to make a straight movement. There's no going forth and back and forth. So that's reason you can categorically say that town two is most efficient. Then another question says, what if you are asked to visit the even number houses only? Which one do you think is going to be efficient? Is it town one or town two? I'll leave this for you to answer. And what if you are asked to visit random houses or house only? Which is going to be efficient? Is it town one or town two? Now, choosing the data structure. For you to choose a suitable data structure, you first of all need to analyze the problem. If you have a problem you want to solve, you need to look at the problem critically and analyze the problem. What kind of data is that problem? Does the problem provide? How will the data, how are they going to be stored? And what kind of assessment or operation with data need? So once you've analyzed all these things, you'll be able to determine also the basic operations that are needed, like the retrieving and processing. All these are the things you need to determine. And at the end, those factors will be able to help you to select the most efficient data structure. So choosing the right data structure will make your operations simple and efficient. Of course, if you choose the right data structure, it will make your operation or the problem very simple and efficient. Or if you choose the wrong data structure, then the problem will become more complex and will not be efficient. Let's see the family tree example. So let's consider that we want to use one-dimensional array to represent a family tree. You remember a family tree comes with node at the top and it is a hierarchical structure. is it possible to represent it efficiently using one-dimensional array? One-dimensional array is just a linear structure. So because it is a linear structure, it is very hard for you to say that you're representing the list with names. And if you represent the list as name, as a list of name, then how will you know who is related to who and their relationship? It is not easy to express that the father gave birth to a child and that child gave birth to 3 children using this one-dimensional array. So obviously it is a bad data structure for this problem. And another one is what if you consider sorting the data structure in 2-dimensional array? Remember, you are still talking about hierarchical data structure, and you want to use linear data approach to solve the hierarchical data structure. That is also not possible because it is not easy to explain the relationship between the elements. Another example is the London Underground. The London Underground is referring to the map, and that can take you from one train station to another train station. So if you consider sorting that train stations using one-dimensional array, it's also not going to work because it is hard to represent this using a linear list. Then another one is also sorting the data using 2-dimensional array. 2-dimensional array will give a solution, but it will not give an effective or efficient solution. The reason is because some lines might also split. And when they split, you have more than 2-dimensional entities, which 2-dimensional array will not be able to cannot be used to represent them. Now we are going to look at the abstract data types briefly. So the abstract data type consists of the data structure and methods. So this says that it is a collection of data and associated methods stored as a single module. But one thing you have to understand is that, let me put it in a different way. So that the abstract data type cannot be accessed directly. So you can access the module, but the abstract data type itself cannot be accessed directly. The data are accessed indirectly through the methods. You can access the methods rather. Now, the abstract data type consists of the data structure we said earlier and method to access the data structure. So with this method here, you'll be able to access the data structure. Don't worry about the method you are referring to. As we progress, we're going to give example of this method. The main key thing is for you to understand that abstract data type consists of data structure and methods. So it is through the method that you can modify the abstract data type. And comparing two of them, the abstract data type is high level, and the data structure is concrete. Another thing is that it is concerned with what to be done, it can do, but data structure is concerned with with how the task is done. Then the abstract data type is implementation, is independent. The implementation is independent, but in data structure, the implementation is dependent. Now we are proceeding to the section where we'll look at the applications using the array data structure, and we will be looking at the stack abstract data type and the queue abstract data type. Starting with the stack. I believe most of you might have been to the bank, and if you go to the bank and if you are asked to queue before you see the cashier, you realize that the first person that came will be closer to the cashier, and the last person will be far away from the cashier. So this is just a kind of an illustration of a queue, but in this case, we are going to start with the stack. So in the stack, we can give an example of a pile of plates, and that pile of plates is, if you, for instance, if you have about 20 plates piled up, you will believe, you agree with me that if you want to take the plate to dish your food, you will prefer to start from the top. And that top you are starting from is the last one that was placed on that pile. So if you compare that with, or if you take another example using these books here, you will believe that the first book that was dropped was this one, seconded by this and this, then the last one is this one. So, but if you want to efficiently access this book and avoiding the chances of the book collapsing, okay, then you have to take the first one on the topmost one. And that topmost one is the last one that was placed. And this is how the stack works. The stack starts from the last one and follows the second one till you get to the first one that was placed. And that's the reason it is said to be last in, first out structure. Last in, first out, because the last that was placed will be the first that will be accessed or processed. This is also a structure to illustrate the stack. Look at this arrow, it is pointing down, and another arrow here is going up. So if this is a stack, these are methods that will be used to access the stack. Now, let's move backward to the slide where we discussed abstract data type. So if you look at the abstract data type, where here, we say that it consists of data structure and methods. So now we are seeing the method, the examples of this method in abstract, in stack data structure are the push and the pop. There are so many other methods which we will see. So this push is the method and the pop is the method. Let's look at the definitions. So the applications anyway. We will also talk about the definitions. I mean, we will discuss the push and the pop, what they do. But the applications, the stack is applied in matching brackets in arithmetic expression. It's also applied for recursive algorithms, which will be discussed in workshop 4. It's applied in evaluating arithmetic expressions, and that will be discussed in workshop 8. Now, there's an activity here which is actually for you to think of other applications where a stack is used. You can discuss that with Darlene during the tutorial section. Now I'm looking at the stack again. So these are the methods in stack. One is the push, as we saw in previous slides. So the push is used to add an item or element to the top of the stack. The pop removes an item from the top of the stack. Then the pick examines the item at the top of the stack. Then empty determines if the stack is empty, and full determines if the stack is full. Then going with these definitions, we will notice some error, which is like throwing an exception. If we implement or perform a push operation in a full stack, just imagine that you have a stack and it's completely filled up, and you still want to put another item in it. So it's going to throw an exception. Likewise, if you want to request for the topmost item to be removed from a stack that is empty, then that's also going to throw an exception. The last one is if you are requesting to determine to examine the item at the top of the stack in an empty stack, then it's also going to throw an exception. The stack after data types manage its storage. It's managed its own storage, so it is not interested in the application that we use it, and it's also not concerned with how the storage of the stack is managed. So the abstract data type manage the storage. Now let's have an illustration of the stack abstract data type. So the stack abstract data type, from where we have the yellow cells to this point, is showing that the elements are being added from 0 to up to this point. Now, one thing we have to realize here is that we are using an array. An array, as we know, is a linear data structure. So the array holds the data, the stack data, and which is inside the abstract data types. Yeah. Then the method that we can use to push or add or remove are the push, the pop, and also the one that we can use to examine the element in the array. So there is an application which will is considering a question, but it also has an algorithm, and it can be found in the activity 1.7.2. So this activity, I'm going to leave this activity for you to discuss it with Darlene during the tutorial section. It says that you have to observe that we do not need to know how the stack is represented and how the operations are implemented. That is referring to that the stack is not consigned. So the stack after data type is not consigned on how the stack is represented, and is not consigned on how the operations are implemented. Now let's look at the Q abstract data types. So the Q abstract data types is a collection of objects organized such that object that has been stored in queue, the longest is the next one to removed. Yeah, so this like a queue. This is the example I was trying to cite earlier. If you've been in the bank and people were asked to stand in a queue in order of the way they came. So the first person will be the person that will be closer to the cashier. And the last person will be far away from the cashier. And you realize also that if they want to begin to be attended to, then the first person will be the person to first attended, and the last person will be at the last person to come will be the last person to be attended to. So this kind of um, abstract data type is refers to as first in, first out. But the first person will be the first person to be treated, and he will go out first. Or it can also be said to be last in, last out, because the last person will be the last person that will be treated. This is also an example of a car in a queue. The first in the lead in the line will be the first to take the road, and the others will just follow just that way. The queue abstract data type supports enqueue and dequeue, full, empty, and first. So, and this is an illustration of how the queue is like. At the point where the entrance, the elements are being entered, that point is called the tail. Where the elements are being removed, at the point where the elements are being removed, is called the head. So we have the enqueue and dequeue. So implementing this, we have this an array that is a linear data structure, and the array starts from 0 to this point. So if we look at this, we realize that if the arrow is going this way, the flow of data is this way, then the entrance is from here, and that is the reason we call it tail. And the first to go out is the first to go in, which is the first in, first out approach. So the header is pointing at the first one to be dequeued or removed from the queue. And that could be done by when any of them is removed, then others we need to move one step ahead. So this is also another expression of the queue and how the tail can be removed. Sorry, how the element can be dequeued from the array. Then implementing using an array 3. So if we're using this array 3 considered using a circular array, or the array as a circle. So where we have the head and the tail, the head is where the first to go out if there's any route for it to go out, and the tail is the entering point. So to enqueue, we have the tail incremented by 1, that is to enqueue it. But to dequeue, we have the head incremented by 1. So this is the approach. If you want to enqueue, the tail will be incremented by 1. But if you want to dequeue it, then the head will be incremented by 1. Observation: due to circular structure, space is reused. And some problems that could be encountered, like in the previous example where you cannot reuse the space, like in this part, you can reuse the space. This will be able to solve the problem. This is another activity that you will be discussing during the tutorial session. We have 2 problems here. The one problem is when you only have one element in the circle, and if you want to remove the last element from the circle queue, give what is the relationship between the head and tail. And in this part, the second problem is if you want to insert an item into the circle with one empty space. So what is going to be the problem or the relationship that you have between the head and the tail? and what is your suggestion for how the problem could be solved. Finally, in every week, there is always an activity like an exercise for you to do. So this, if you go to the module, you will see some exercises and also some multi-choice questions that you can answer. You have to analysis exercise and coding exercises for each workshop are available in the booklet and on the module. So this is where we are going to end this section. Thank you so much and see you during workshop 2. Goodbye.